Is my slide is visible from your end? Is my slide is visible from your end?
Yes, sir.
Okay. Okay, so we are discussing about the different electrical and mechanical features of our locomotive. Now we have already discussed about the starting and speed controlling of the DC motor traction, DC traction motor. Okay, so here we can observe it from the pictorial point of view. Okay, so it is called the rheostatic control or dynamic. You say like the dynamic braking type of concept. Okay. By these configurations, okay, why it is called geostatic control? By this configuration, both the you can both the operations can be done. Okay, so you can you can controlling the speed of the motor. Okay, as well as you can dissipate the additional energy when you want to do the dynamic braking or rheostatic braking. Both the operations can be possible. Okay, how is it possible? Okay, so here you can see that that series motor is there. Say that additional resistance are connected series with that motor. Okay, and basically here you can see the armature winding. Okay, so this is field, you say like that, field, and it is your armature. Okay, motor armature. So here you can see that contact are there. Okay, so one, two, three, four. Okay, so contacts are there. Okay, suppose when this is line contact. Okay, so trolley, and this is trolley wire, or you say like that. In case of tram, it's a drum type of control you can observe. So both the possibilities, how is it work, you just see. Okay, first when starting conditions. Okay, at the means initial conditions, at the point of starting, what you need to do. So at that situation, that the trolley contacts, it will be automatically turned on. Okay, it should be on. Okay, then you see like that at that starting conditions, that all the resistance, okay, all the resistance are in the series with that motor. Okay, so all the resistance are there. Now what happened that then gradually, okay, after starting of your motor, what you need to do, then gradually you have to cut the additional resistance. Okay, how to cut that part? So what you are doing, so first you turn on this path. Okay, if you turn on this path, then what happened? This path will be turned on. If that contact is turned on, then what happened directly, you can see like that. So this path, okay, this path is bypassing, okay, the current from this resistance. Why? How they are bypassing? Basically, you know that there is some resistance and this is short circuit path. Okay, so what happened? The current will be flowing from this, it can bypass this resistance. Okay, for the condition, first this switch will be turned on. Then what you need to do, in second condition, that second switch will be turned on. If that switch will be turned on, then what happened? That these two resistance, okay, first two resistance will be bypassed. Okay, the direct current will be coming from here to here. Okay, from that point to that point. So both are equipotential points. Okay, so it's true that part will be bypassed and current will be flowing like that. So then finally 3 and 4. Okay, then entire resistance will be bypassed. Okay. Then what you are doing, then you want to go for rheostatic braking or dynamic braking. So what we need to do, then first you have to turn on again when you are doing the dynamic braking. So how much maximum resistance you can add, okay, so that you have to think about it. Okay, directly what you are doing, so you just turn on that switches, okay, and turn off that contact one. Okay, so all the contacts you are turned on, 1, 2, 3, 4, and turned off that contact L, trolley contact, you just turned off. Then what happened? The additional energy will be bypassing, okay, will be dissipated through this one. So where will be your another path? Another path definitely will be there. So that point will be directly connected to that path, return path will be there. This is your ground, another path will be connected over there. So directly what happened? Additional energy will be dissipated through the resistance. So by this way you can okay, so by this way that starting condition you are gradually starting your motor. Then if you want to speed control conditions, okay, so speed control conditions means armature terminal voltage, you can control the armature terminal voltage. Okay, so 4 resistances are there. Okay, so individually one by one you are just turning on. Then what happened? That entire voltage, so current will be unchanged but the voltage will be different. Okay, initially it was total V will be there. Now that resistance will be one by one resistance is turned on. Then what happened? It will be V1, V2, V3, V4. So 4 voltage will be there, sub voltages. Okay, so and that motor terminals will be there. That is VA. Okay, armature voltage VA and this is VF. So V1 plus V2, V3, V4 plus VA plus VF equal to V. Okay, so you are subdividing that voltage. Okay, automatically you are turning on that voltage means motor speed will be automatically controlled. Okay, sometimes it will be controlled, sometimes it will not be controlled. Okay, so motor speed will be varying. Okay, so by this way you can change. By this way you there are 3 purpose will be going on. Number 1 purpose, at the starting resistance you can able to start your motor. Okay, that additional path, additional resistance is behave like a starting resistance. That is condition 1, situation 1. Second situation, you can by this resistance path you can also controlling the speed of the motor. Okay, and third situations, that due to the turning on that contacts were, okay, that contacts are there, 1, 2, 3, 4, that 4 contacts are there, you can bypassing the current. Okay, sorry, you can if the return path will be connected with your system, then what happen, you can dissipate the additional energy or stored energy through this resistance for the dynamic braking. So 3 conditions can be done in these situations. Okay, then series parallel operations also be there. Okay, so before going the series parallel operations, what are the main important points? I am just telling you. The series motor, okay, a series motor can be started, okay, can be started by connecting the external resistance in series. Okay, external resistance in series with the main circuit of the motor. At the starting instant, since the back EMF developed by the motor is 0, therefore the resistance connected in the series with the motor is maximum and of such a value that the voltage drop across it with the full load related current is equal to line voltage. Okay, so you can understand that voltage drop will be there. If you add all the voltage drop, so you can get that equal to the line voltage or motor terminal voltage. Initially back EMF, how much value is it? Initially back EMF is 0. For the starting condition, it can be work fine. Okay, as the motor speed up, okay, then condition 2, this is one situation, this is second situation, motor speed up. Okay, speed controlling, back EMF developed by the motor increases, therefore the external resistance, okay, external resistance is gradually reduced the order to maintain the current constant throughout the starting or the accelerating period. Okay, I hope all of you able to understand. Okay, in this method there is a considerable amount of energy loss. Okay, so in the external circuit, so that is one negative point. And dynamic braking, the main problem is that huge I square loss will be there. Okay, the register employed are the designed for the short time rating and not for the continuous rated conditions. They are required to carry current only during the starting of the motor. Okay, that resistance. Okay, the motor can therefore have only one speed characteristic. So motor having one speed characteristic, but that resistance in reality, in practically, that resistance can be used for starting of the motor, then speed controlling of the motor, as well as dynamic braking of the motor. So multi-purpose uses, that resistance you have, that resistance there is a multi-purpose uses. Okay. Now the series parallel configuration, series parallel control. Okay, so you can understand that one locomotive on loco coach. Okay, so there are 6 wheels. Okay, 6 wheels means a front side 3 pairs of wheel. In one locomotive there is a 12 wheels. Okay, one loco engine. Okay, so 12 wheels are there. So first 3 set of wheels will be front side, another 3 setups will be pair of 3 setup will be back side. So individual wheel set will connected one traction motor. Okay, so there are 6 pair of wheels means total 6 traction motors are there. Okay, now the condition is that all the traction motors are work independently. Okay, there are different configurations are possible. Okay, they can work independently, they can also work associate manner also, means all the traction motor can work in series conditions, parallel conditions, shunting conditions, and any of the combinations, series parallel. Okay, series parallel, different configurations that can be worked. Okay, as per the combinations. Okay, so how much rating is required. Okay, based on that they can be, you can arrange them and you can control them. Okay, so basic thing is that what is series parallel control. Okay, so here you can see 2 motors are there. Okay, so motor 2 and motor 1, this is motor 1, motor 2, both the fields are there. Okay, so you are connecting them in the series. Parallel means more current if the loads are huge. Okay, so current drawing by the motor will be more, so you can configure the motor in the parallel configurations. Okay, and in the case of what, you can subdivide the voltage. Okay, you can subdivide the voltage. Okay, for high voltage application, so you can combine both the motor in series and you can control the voltage throughout the motor terminal. Okay, and you can controlling the series of the both the motor. So that is happened here. So you are giving that one voltage potential over the terminal and resistance R is there, it is your load resistance. Okay, and now that slider is there, you can move the slider, so motor voltages are changing. Okay, so motor terminal voltages are changing, so you can control the speed of the motor, you can controlling the speed of the motor. The main disadvantage, okay, the main disadvantage of wastage of electrical energy. Okay, this the way main disadvantage, wastage of electrical energy in rheostatic control. Okay, that is called rheostatic control, is a part of overcome method where 2 or more motors are working. Okay, in this case 2 motor, the motor are the first connected in the series and other one connected in the series with each other and starting and control the resistance as per the figure, so you can control them. So here you can see both the motor has been controlled, that we are talking about. So if the both the motors are combining in series, so total voltage will be splitted down. Okay, so if total voltage is V and the rating is more or less same, both the motor 1 and motor 2. So this is your motor 1 and motor 2, voltage will be more or less same. Okay, so the voltage will be splitted. Okay, V by 2, V by 2. Okay, so what happened? Additional resistance. Okay, additional resistance is gradually cut out. Okay, by the controlling the motor, attain the speed and finally control resistance totally removed. Okay, finally the resistance totally removed. That resistance is only required for how much time is required to back up the or develop the back EMF. That amount of time you are just connecting them. Then each motor has 1/2 of the line voltage across it. Okay, as shown in the figure. So here you can see the diagram. Okay, with the fast running positions. Okay, with the fast running positions, the positions for any given value of the armature current, each motor will run the half of its normal speed. So voltage will be the half. So definitely speed, there is a effect on the speed. Okay, if the voltage will be reduced. Okay, then what happened? The next step. Okay, 2 motors are connected in parallel. Okay, so both the motor connected in parallel. So motor 1 and motor 2. So total voltage V is there, V is appearing across the motor, and that additional resistance is required at the point of starting. Okay, so current is splitted. Okay, if the I dash current or I current is there, so I by 2, I by 2. As per you are considering that motor rating is more or less same. Okay, the next connected the series with the variable resistance are shown in the figure. Okay, so you can see their configurations. Now other type of configurations also possible. Here you can see different configurations. Series parallel configuration, combinations of series parallel and the resistance control of the DC series motor. So that we are talking about that how much if there is a 6 motor. So different combinations also possible. We are only considering 2 motor and show you that what type of the different configurations. Okay, if there is a 6 motor, so that type of configurations you can also see. So you can add another 4 motors and their different configurations. Okay, so here you can see the resistance is gradually cut out. Okay, so in the previous case, the resistance is there, that R resistance is there. Okay, now what you are doing? So resistance is cutting out. Okay, that resistance is not there, removed up. Okay, and I is there. Okay, only I current. So when that resistance was there, so the current was I dash. Okay, now resistance has been removed. Okay, now total current is I. As the motor attains the speed, and finally when this resistance is totally removed, okay, totally removed from the circuit, and the figure you can see over there. Okay, so I by 2 motor, first motor, second motor, and their field, both the motor, and total current is I. So potential is V you have given there. Okay, so here you can see that other options. Okay, so 2 resistance are there in the series. Okay, first case that both the resistance are in both the resistance has been considered. Okay, this is your plus, another terminal, it is your minus, the return path. Okay, both the resistance is there at the time of starting. Then what you are gradually you are decreasing the resistor value. So the slider you have moved over there. So one resistance, that resistance has been bypassed. Okay, that resistance is bypassed. Okay, then you just connect, just shifting that slider to here. So both the resistance are bypass. So in the series combinations, okay, that series combinations. Now what you are doing? Then both the motor connected in parallel. So both the motor you are connected in the parallel. So initially what happened, 2 resistance at the series with that combinations. Okay, for limiting the current. Okay, at the starting conditions. Okay, so these all 3 configurations for the series. Now we are discussing about the configurations for the parallel. So first two resistors are considered. Now you are considering only one resistance. Okay, one resistance you are considering, that first one you have not considered. This is removed. Now what you are doing? Then both the resistance is removed. Okay, both the resistances are removed. Directly that you are connecting that motor terminals, both the end. Okay, so this is one path, this is another path. Both the motor terminal has been connected. Okay, now you are using what, that resistances are there. Okay, so you can also utilize these 2 resistance that we are talking about, 4 resistances here. Okay, so here you can see additional resistances are connected across your motor field. Both the cases, both the motor field you are connecting one resistance. So when it is required, this is required for field weakening method. First we are doing the starting. Okay, starting of the both the motor in series conditions. Now the motor is working fine. Okay, both the motors are connected in series. Okay, after that what we are doing? We are doing the parallel combinations. Okay, 2 motors are parallel. Okay, so both the cases you can see they are parallel. Okay, so parallel conditions, then we are connecting 2 resistance in the series. Okay, then one resistance, then both the resistance is bypassing. After that what happened? Voltage control for the speed of voltage changes, for the speed control of the motor is over. Then you are doing what? That if you want to go beyond the rated speed, so what you need to do? That field weakening method you have to do. So then you are adding another 2 resistance across your field. So these 2 resistors also you can involve over there. Okay, so what happened? You have to design the system so much, so optim means you have to design the system such a manner so it can carry only optimum space. Basically, additional thing you have to provide there, but you are using the system for the commercial purpose. Suppose good carrier, passenger carriers. If you are incorporating more number of resistance, more number of motors, okay, 6 motors are already there. Okay, so normally 3 6 motors are there. Otherwise, for our normal EMU, one motor coach carry. Okay, one motor coach carry one motor coach carry normally 4. Okay, so it totally based on the rating of your machines. Okay, if more number of if you want more number of motor or more additional part for that goods carrier or passenger carrier, so that having huge weight. Okay, so that place can be configure can be minimize by using the optimum sizing of your components. Okay, optimum number of your components. By that way you can minimize the weight of your overall system. That's the beauty. That's why same thing you are using in different manner. Okay, I hope all of you able to understand up to these questions. If you facing any difficulties, you please ask me. Okay. Now combination 3 that we are discussing about the field control. Okay, so what is our field control? So here you can see for the field control.
Field
Hello,
flux. The controlling the field flux through current into the field.
I'm not getting what happened. Please tell me.
So you were asking now what is the field control? So I was telling that the controlling the field current, so that we
Hmm.
can control the flux.
No, no. Actually, that flux here we are not varying. Okay, practically we are varying. That we are talking about field weakening. Na? So that parallel path here you can see. Okay, there is the additional resistance. Okay, so if we are using some slider with the resistance, so we can vary that one. Okay, so we can vary the flux. Okay, if we are able to vary the flux, so automatically motor speed will be vary. Okay. Hello.
Yes, sir. Yes, sir.
So that is not given, but practically that points are there. Okay. So for varying option is there. Okay. Just for pictorially represented. So now we are going to use that field control method. Okay, so field control method means here you just see that additional resistance are there. Now that slider is there. Okay, that we are talking about. And that similar type of thing you can also using tapping of that field. Okay, so tapping of the field also possible if you change the pointer or slider, so automatically it can be controlled. So it is field this is field divider methods for the speed control of the DC motor, and this is tap field control of the DC series motor. Okay, so both the cases you can see that voltage is there. Okay, so plus minus voltage is there, currents are there, so current division. So divider, if the current is dividing over there, so that's why it is called current divider. Okay, so resistances are there. So rest of the portions is more or less similar like your previous concept. Okay, so what happened here? So you know that directly motor speed is inversely proportional to the flux. Okay, so motor is speed of the motor is inversely proportional to the flux. Okay, so when that voltage is containing constant voltage. Okay, so therefore if you want to weakening, you know that configurations. Okay, so VT terminal voltage equals to EB plus IARA. Okay, so EB plus IARA, so VT minus IARA equal to what? EB. EB equal to Zn 5P by 60A. So Z is constant. Okay, N we are considering that variables. Phi is constant. P means number of poles, that also constant. 60A both are constant. Okay, so yeah, and Sorry, Zn. Okay, so phi sometimes constant or sometimes it can be vary. So we are considering the field control. So phi may be vary. So it is coming that k into n into phi directly it is coming. So you can say like that EV minus IARA equal to k phi into n. Okay, or n equal to EV minus IARA whole divided by k into 5. Okay, so what happen, you can see that other components may be constant, so you can see that n directly inversely proportional to the 5. So that's why we are changing the flux. Okay, that is also known as flux weakening method. Okay, without changing the polarity of the field. Okay, so speed can be varied by the varying the flux. It can be varied either one, the connecting the variable resistance known as the divider in the parallel with the field winding. Okay, the divider path. Another one is cutting out the sum of the field turns. Okay, so tappings are there. Okay, so tappings are there. You are just changing the tappings. Okay, both cases flux can be reduced, but that reduction should be within the range of critical zone. Okay, so it should not be below the critical zone. So there is some fixed zone. Okay, so you can control up to that limit. Okay, you cannot go beyond that one, and you cannot go after that one also. Therefore, this method is known as the field weakening method, and speed of the normal can be obtained. So how much you can extend up to 15 to 13% above the normal speed. So by this method. Okay. The difficulties is the traction motor. Okay. So design difficulty arising in the traction motor if you go beyond of this. Okay. This method no use for starting purpose. By the field weakening method is speed control necessary, changing the gear ratio can be eliminated. Okay, so that all the time pinion gear, all the cases are there. So anyhow, if in transmission you can changing the gear values or number of tooths, so automatically it will be replicated. Okay, just like your changing of the turns ratios. Okay, it's just giving you some gain value. Okay, providing you some gain value based on their diameter. Okay, so number of tooth. Okay, so tooth. So based on that, you can controlling or you can fixing up the speed. Okay. So here we can see some chopper control, DCMU or ACEMU. Both the cases we are using the same configuration, same type of configuration, not exactly same configurations. Okay. Chopper unit means we are now power electronics based control is already there. So beginning of some of the discussion we have discussed about how the power electronics based concept is associated with your system, power electronics based. Okay, so that basic portions you have already aware about. So we are using the catenary and contact wire. So based on our requirement. Okay, so here we are considering that positive. Okay, so DC overhead line. So in case of metro rail, okay, that all the time it should not be like that only DC. Okay, but if there is no DC, if there is not the mention of DC, so internally that AC is converted to the DC for this purpose of the traction motor. And for some of the metro rails, okay, so we are directly giving the DC. Suppose in Kolkata metro you can see that in the DC high tensions. Okay, so that high tension line, but it is not overhead line. This is just this power line is just line beside of your railway track. Okay, so there is a connector that directly connecting with your rail that power bus. Okay, and sliding over there, and continuously it's collecting the power from your path. Okay, so what happened? So in that case, but it is pentograph. Pentograph means you are collecting the power through that path. So pentograph. Then isolator is there that we are talking about. So based on your mainline, based on your railway service, your isolators types also has been changed. Types also been changed. Okay. So circuit breakers are there. That what is this? That is your insulators. Okay, circuit breaker, insulator, or you can say like that contacts. Okay, so that all the insulators are there. Then so inverter means you are converting the DC to AC for if you are using induction motor drives. Okay, so inverters are there. So inverter can controlling the speed of the motor. So you know that space vector concepts. Okay. So so more sophisticated controlling of your speed of your machine, speed of your motor. So that induction motor you can also use. So DQ control, so you are converting that ABC to DQ for controlling that smooth controlling that of your induction motor. Okay. Then what you are observing? Okay, so then what you are observing, that inverters are there. Then for the traction purpose, another inverters are there. So that is using for the transformers. Okay, so DC to AC conversions are there in the transformer. Then transformer, what the purpose of the transformer? It having that it is three winding transformer. One winding, that is main winding, is for your traction motor, but here we are using the transformer for AC output and the charging of your batteries. Okay, for the backup system. Okay, so AC DC rectifier is there from the transformer variable. So then battery is charging. Okay, so from the figure, what we can observe that DC EMU. Okay, DC EMU means DC supply from the overhead conductor is collected by the pantograph and given to the converter. So three types of converters you are observing here. Inverter means DC to AC converter. Okay. Again that DC to AC converter, then transformer, then AC output. Another output is there that again converting AC to DC. It's a not directly rectifier. It's a bidirectional converter. AC to DC bidirectional converter. So battery can be charged through this path as well as battery can be discharged. Okay, that's why it's a bidirectional converter. Okay. Inverter is a device. Okay, inverter is a device that can convert DC to AC. One inverter gives three-phase AC output to three-phase traction motor. Okay, one is there for three-phase transformer, another is using for the traction motor. Okay, other inverter gives three-phase out to three-phase transformer. The three-phase supply can be used for air conditioning, fan, and compressions. Okay, that main lines are main operations, three-phase operations. The transformer output is converted DC, okay, by means of rectifier. This DC is used for the battery charging control. Okay, but it's not the single directional converter, it is bidirectional converter. Okay, so battery can be charged as well as discharged through this converter. Okay, that's why it is a bidirectional converter. Okay, if it is not a bidirectional converter, it cannot be discharged that manner. Figure shows that the general block diagram of the electronic power and auxiliary service on the DC EMU. Okay, so from here you can understand how it is working, how DC EMUs are working in current scenario. Okay, but current scenario not exactly this diagram, it's different. But I don't know now the technology has changed or not. Okay, I am talking about the technology. It was 10 years back, 10-12 years back technology. I am telling right now what technology. Definitely there is upgradation of the technology, but basic idea cannot be upgraded. Basic idea will be same. It will be basic idea will be same. Okay. Okay, then we'll start from that ACEMU from my next class. Okay, so then there is some continuations of these portions. Okay, in my next class we will start about that ACEMU and that other that system. Okay, some of the few slides are pending, so I think within two classes that portions will be completed. Okay, so thank you all of you. If you have any queries, you can ask me. Is there any query? Okay, I think there is. I think there is no query from your end. Okay, so we can stop our session today.